Well, hi everyone, and thanks for joining me on this webinar. I'm going to do kind of a quick overview of some of the new stuff in Dplyr 0.7. We'll start with kind of a bunch of smaller stuff. None of it's kind of particularly exciting by itself, but in aggregate it adds up to just relieving a whole bunch of small pain points in Dplyr. Then I'll talk a little bit about databases, and then finish off by talking about Tidyeval, which is a new system for programming in Dplyr. So there should be plenty of time for questions. I'll stop after each section and take any that look particularly interesting to the whole crowd. Okay, so the first thing I wanted to mention, if you don't already know about it, Dplyr has a website now, dplyr.tidyverse.org. That's a great way if you want to see the examples and the code, see the vignettes, and generally get an overview of the package. So that's a great place to start if there's anything you want to know more about Dplyr after this webinar. I also wanted to mention briefly the TidyVerse package. I'm just going to use, if you haven't heard of the TidyVerse, or the TidyVerse package just basically makes it easy to get a bunch of packages that work well together. So when you install it, it installs all of the packages in the TidyVerse, and then when you load it, it loads the most important packages. So here I'm showing you the development version, which in conjunction with development version of RStudio gives you this pretty colorful display telling you which packages are loaded. So you can see here I'm using the development version of Dplyr. It gives you a little bit of information, a little bit of session info, so you can, if you're having problems, you can, if your code works on your computer, not someone else's, you can often track down the difference to one of these issues, and then finally tells you what are the functions that the TidyVerse is masking from base R or other packages. So with that, let's dive into some of the new stuff in Dplyr. The first one is that there's two new data sets that if you're teaching Dplyr might be handy, and we'll be using these more and more in the examples to illustrate more sophisticated features of Dplyr. So the first one is the Star Wars data set, which contains a bunch of information about the characters from Star Wars, which come from the SWAPI, the Star Wars API site. And one of the things that's different about this data set compared to other data sets and other packages is this contains a few simple list columns. So for example, you can look at this films column, and that tells you it's a list column because a person may have appeared in more than one, or I think they've all appeared in more than one, but some of these other Star Wars vehicles is similar because someone might have not traveled in any vehicle, or they might have traveled in more than one vehicle, hopefully. Okay. So Star Wars, some fun data about the characters in the Star Wars universe, and contains some list columns to practice your list column skills on. The other new data set is this data set about storms in the Atlantic. This contains a whole bunch of data from the, I've forgotten where it's from, hopefully the documentation will tell me, from the NOAA Atlantic Hurricane Database. So there are 198 storms in here going from 1975 to today. We can do a quick plot and you can see approximately where they start out and where they end. So this data set has a rich grouping structure because you're probably going to want to group each storm and then compute various summary statistics on. So a great data set for practicing your group by skills. So two new data sets. There's a handful of other data sets that you can read about in the release notes or the blog posts that are just really simple data sets if you want to teach people basic join functions or practice them yourself. There's one new important verb in Dplyr called pull. Pull gives you a single column. So this has been a long time source of frustration for many Dplyr users. If you use select and give it a single variable name, it's still going to give you a tibble back. It's going to give you a tibble that just has a single column. If you use pull, it is going to give you that single vector. This is basically equivalent to this code you could do already using the $, but it works on database backends. And the other thing that's sometimes handy is you can use it to select columns by their position. The default, you can select from the front, from the left-hand side, if you give it a positive number, or you can select from the right-hand side if you give it a negative number. And indeed, if you don't give poll anything, that is the default. It's going to take the rightmost column by default, kind of under the assumption that if you've just created something and you probably want to take a look at it. So that's poll. The new data sets, those are kind of the biggest of the small new things. We put a bunch of work into improving the error messages. So hopefully, if you do something by accident that you didn't mean to, you should now get a better error message from Dplyr that tells you both where the problem is, i.e. the column, what it was expecting, and what you gave it, which should hopefully make any problems easier to diagnose and debug. We also put a bunch of time into encoding support in Dplyr. Probably the case that affected the most number of people was if you use CJK, Chinese, Japanese, or Korean languages or data sets containing those languages on Windows. You basically could not use Dplyr without a huge amount of pain. So that should now all be resolved. And if you discover any differently, please let us know so we can fix that. We also made some changes to make joins and similar functions behave better when the columns you're joining have different encodings. I just wanted to still illustrate one little example of this, which just to illustrate how painful encodings in R can be, because here I just created a string, dates the word élève, which if I remember my high school French correctly, means student. And when you print these two strings out, they look identical. And indeed, if you ask identical, are they the same? It says yes. Well, yes, they are the same. But if you go and say, well, tell me the binary representation of this string using chart or raw, we can see that they're actually different strings. And that's because they have a different encoding. So you can see X is encoded as UTF-8 and Y is encoded as Latin 1. So now Dplyr should just kind of handle this problem for you automatically. If you're using readr and other packages in the Tidyeverse, you should always get UTF data as your input. Generally, that's easier to work with. Just stick with UTF-8 rather than messing around with different encoding. So whatever your encoding is on disk, load that up, convert it to UTF-8, and use that in Dplyr. So again, by and large, this problem should just go away behind the scenes without you having to do anything. One other tiny little feature that's quite nice is now that CaseWin function works inside mutate. Maybe you have not seen CaseWin before, but it's a really useful alternative to a whole bunch of nested if-elses. So I'll show you a quick little demo of using CaseWin, just a simple case, and then show what that looks like now that it works inside mutate. So here I'm going to use CaseWin to implement the sort of infamous FizzBuzz programming challenge. And basically in the FizzBuzz programming challenge, what you have to do is print out a vector of 50 or 100 numbers, but when that number is divisible by 5, you need to print fizz. When it's divisible by 7, you need to print buzz. And when it's divisible by 5 and 7, you need to print FizzBuzz. And CaseWin allows you to express this very succinctly. It says basically we use the formula. The tilde is basically kind of an if-then. So if it's divisible by 35, then return FizzBuzz. If it's divisible by 5, then return fizz. If it's divisible by 7, then return buzz. Otherwise, for everything else, true is always going to be true, convert it to a character. So CaseWin operates sequentially. So as soon as the first thing is true, it's going to ignore the rest. So when we run this on my vector 1 to 5, we solve this FizzBuzz programming challenge. 1, 2, 3, 4, fizz, 6, buzz, 8, 9, fizz, and so on. A more realistic use is to use it in the context of a data frame. It's really useful when you need to recode variables. So here I've just kind of made a very well, somewhat silly example using the Star Wars data set where I want to categorize the different characters based on a combination of their height and their mass and their species. So I'm saying if their height is greater than 200 centimeters or their mass is greater than 200 kilograms, I'm going to say that they're a large type. If they are a droid, I'm going to say they're a robot type. If they're a human, I'm going to say they're a human type. Otherwise, so true means otherwise, I'll just mark them as other. So when I run this, I get a new column called type, which succinctly expresses exactly how I want to do that transformation. And this is much easier in doing the kind of the equivalent set of if-else statements, which would look like 200 mass greater than 200 in large. Otherwise, I need to do another if-else with species equals droid. And if you've ever written any of these kind of nested if-else statements yourself, you know this gets painful really, really quickly. Also, a whole bunch of other bug fixes, mostly just little stuff, but you know, whenever you hit a bug, no matter how small it is, it's always frustrating to deal with. So that's kind of a summary of the few of my most favorite small features in Dplyr. I'll take a quick look at the questions just to see if anything has come up. I see someone has asked about if a data set does not fit in memory, which we're going to talk about next. Oh, and if you haven't seen this operator before, %%, this is not a Dplyr thing. This is a base R thing. This is the modulo operator. So this expression basically means if it's divisible by 35 with remainder 0. And yes, CaseWin works with all of the Dplyr verbs, summarize, mutate, and so on. If you're going to use if you're going to use CaseWin with summarize, I guess CaseWin works with summarize for some definition of work. It's basically a vectorized function, which means it gives you the same number of outputs as the same number of inputs as the number of inputs, which means it's most fitting to work with mutate. With the summary functions, you generally want a function that takes multiple values and returns a single value. So CaseWin, you could probably make it work with summarize, but typically you'd need to use some kind of summary function probably around the outside. That doesn't make any sense in this case, but maybe you could say paste. And when you supply the collapse argument to paste, that becomes a summary function because it's going to take n strings and return a single string. Okay, so next I wanted to talk about the new database support in Dplyr, or the improved database support in Dplyr. Again, if you want to learn more about this, the best place is the website Dplyr. So Dplyr is the package that now provides all the database related functionality in Dplyr. By and large, you will not need to know about this package. You will generally not need to attach this package, so Dplyr will load that for you. You'll need to install it, and you'll need to know that this is where that code is if you need to get help. So the biggest change in this version of Dplyr is, in this version of Dplyr and the matching version of Dplyr, is that there's much, much better integration with the DBI package now. So the DBI package is a uniform interface to many, many, many different databases. So to use the DBI package, you always pair it with a database specific R package. So for example, I am going to create a connection to a database. So to create a connection to a database, you use the db connect function from the DBI package. And the first argument to that function is the database driver, or the R package that provides the database connection. So here I'm going to connect to it a SQLite database, which is provided by the SQLite package. If you haven't heard of SQLite before, this is a fantastic place to start with databases, because the database is actually included in the SQLite and the R SQLite package. So most database systems, you've got like a database server, which can be a pain to set up and get running. With SQLite, that database is actually bundled in the package for you. So it's really, really easy to get up and going. And I'm going to cheat even further. I'm going to make this even easier to get up and going with, and I'm going to use a temporary in-memory database. So I have a connection to this database, and you can use DBI to connect to all sorts of packages, SQLite, MySQL, Postgres, and then I'll talk a little bit later about some of the new enterprise databases that we're working to build support for at RStudio as well. So I've got a connection to that database, and now I am going to use one of the DBI functions, DBI write table, to copy a data frame to that database. And so what's new in this version is basically the seamless interaction between DBI, which is a very low-level function that allows you to execute SQL queries directly if you know SQL, and DBI and Dplyr, which is a much higher-level interface, which will write those SQL queries for you. So now I can say, create a new tibble from this connection. I'm going to call this, the database table is called empty cars, and I'm going to call this R object empty cars2 just to avoid confusion with the previous empty cars data frame. So I print this out. You'll see that this is now a remote table. It's a table in a database, and in fact, in that database is a SQLite database. And the neat thing about using Dplyr with a database is that Dplyr will generate the SQL for you. And there's been a bunch of improvements to the SQL generation in this version. And one of the really nice improvements is this optimizer that was contributed by H. Hiflin, which reduces a lot of the subqueries that Dplyr added previously. So let's take a little example. I'm going to take this empty cars2 data set. I'm going to filter it. I'm going to select some variables, and then I'm only going to look at the top 10. And if I just run this code, what Dplyr does behind the scenes is generate the SQL query, sends that to the database does all the work, and then returns the results. If you want to see the query that Dplyr is generating, you can use the show query function, and you can see here this query is probably pretty similar to what you'd write by hand. We're going to select these variables from this table where this condition is true, and I'm going to limit the results to at most 10. Now, in the previous version of Dplyr, this would have generated at least 3 subqueries, which in some databases can degrade performance and definitely makes it harder to understand what Dplyr is doing when it generates the SQL for you. We've also added more support for type coercion. So if you need to change the type of a variable in the database to a character or a vector or an integer, you can use the R functions you're familiar with, and those will automatically be converted behind the scenes to the appropriate SQL. So here you can see I'm using transmute. If you haven't heard of transmute before, it's a variant of mutate that just only keeps the variables you specify. It doesn't keep all the other variables. So you can see what this generates. Oops, forgot the pipe. You can see what this generates. This isn't quite as optimal SQL, but you can see that it's generating this cast, which is how you change the type of a variable in SQL. And again, and here I used pull as well, just to pull down that variable from that query out of the database. Another thing that's changed in the latest version of Dplyr is that there was an annoying bug whenever you're using in. Now this always generates the correct SQL. Previously, we would forget to put the parentheses in here, which is valid R code, but not valid SQL code. So baked in to Dplyr, there's translation support for the major open source databases, SQLite, MySQL, and PostgreSQL. We are working to add more support for commercial databases. So this version also includes translation support for MS, Microsoft SQL Server, Apache Impala, and Apache Hive when you use them through the ODBC package. So the ODBC package is another package we've been working on recently. It is a DBI compliant backend for ODBC databases. So this makes ODBC is a very popular standard for connecting to databases. This makes it very, very easy to connect to a whole bunch of commercial databases that do not have the best support in R right now. So this is something we're working on hard at RStudio at the moment. You'll hear more from us in the near future, but we want connecting to any database. We want to make it as easy as possible to get your data from wherever it is, whether it's SQL Server, whether it's Oracle, whether it's Postgres, whether it's Redshift, to get that data from wherever it lives inside your organization and into R. And we've been working on a whole set of there's like 10 packages involved in various ways at the moment. We'll be sharing that vision with you in the very near future. There's a whole bunch of other small improvements. The SQL translation, again, just little things. If they affected you before, there'll be much less pain now than there was previously. But the other big thing that a lot of people have been clamoring for is support for schemas. So I'm just going to do a little demonstration of that. I'm going to create another database, another SQLite database, and I'm going to attach it. This is the way that SQLite allows you to work with multiple schemas. SQLite's kind of a very small database. It doesn't have like amazing schema support, but at least allows you to demonstrate the feature. I'm going to create two tables both called DF. One is going to be the iris data frame, and one is going to be the empty cars data frame. And I'm going to put these in different schemas. So now Dplyr has this new function called inSchema, which allows you to be specific about what schema you want to look for the table in. So here this is saying look in the auxiliary schema for a table named DF. And when we do that, what you can see here basically is that when we refer to this, we can now be explicit about what schema we want to get our table from. So if you don't use schemas, this does not affect you at all, but many big corporate databases use schemas extensively, and this should make your life much, much easier. So that was a quick overview of the new database features in Dplyr. Let's look for a few questions. So one question is if there's plans to support that use the bit64 package to support 64-bit integers. That's not going to happen at the Dplyr level, but that's work that's in progress on the DBI package, and unfortunately it needs work in all of the individual database backends. That's something that I think we've added or we're in the process of adding to the DBI specification, and that will kind of slowly roll out to the various database backends over the next 12 months, and I'm pretty sure we've added that support into the ODBC package. A few other questions about specific databases. Yes, we're going to add support for Oracle. Yes, we will add specific Redshift support. The translation in general it's obviously documented more on the Dplyr website. It works best for the types of simple expressions that you do when you're typically filtering and summarizing and mutating your data. This is not a translation. You can't just run any arbitrary R code on the database. Obviously, there's no way to run like a linear model on the database or a generalized additive model on the database. Databases just don't have support for those. So the goal with the SQL translation in Dplyr is to allow you to kind of iterate quickly. Typically, there are a very large number of kind of big data problems where the key problem is just getting the right small data. And you need to be able to iterate quickly between the data, getting the right data into R. And rather than having to constantly context switch between Dplyr and R code and SQL code, you can focus on just writing R code, and Dplyr will take care of writing the SQL for you. So this is in practice. For most of the people I've talked to, the translation just works. If it doesn't work, you can always write the SQL code yourself. But for the type of simple stuff that you're typically doing when like summarizing or subset, the translation is really, really good. Okay, so let's finish off by talking about Tidyeval, which is kind of the biggest and most complicated new feature in Dplyr. And just before I sort of talk about exactly what this is, I want to like illustrate the problem that we're trying to solve. And so here I've got a little tibble and I'm doing some data analysis with it. And I'm basically, each of these three clumps of code, I am doing the same summary, but with a different group. And so to do this with Dplyr, you might be copying and pasting your code. And that's great. I think a rule of thumb is it's fine to kind of copy and paste up to like 3 times. But as soon as you go beyond that, it's worth the investment to write a function. And that's because often, you know, the thing that you're doing is changes, or you discover a bug. And if you've copied and pasted that code everywhere, tracking down every single instance of that bug can be really painful. So it's a really good idea to turn repeated code that you've created by copying and pasting into a function. But this is hard because Dplyr lacks a property called referential transparency. So let me try and describe this quickly. So basically, and I've created 2 simple functions, one that just multiplies its input by 10 and one that adds 10. And normally when you're writing functions in R, you can extract out kind of a expression or part of that function call and assign it to a variable. And that doesn't matter. You can do that as much as you like and you always get the same result. That's what's called referential transparency. You can create new variables and it doesn't change how the expression is computed. But this doesn't work with Dplyr because you can't kind of pull out that expression. You can't pull out this repeated code, this G1, this G2, and just G3. You can't assign that to a variable because there is no object called that. Because inside the Dplyr expressions, to make your data analysis, your data manipulation as fast and fluid as possible, in here, this variable refers to a variable inside the data frame. So this is one of the features of R sometimes called non-standard evaluation, where we're taking this expression and we're evaluating it in a special way. And this is really great because it allows you to save so much typing. You're not constantly having to type the name of the data frame again and again and again in your expressions. But the downside of this implicitness is that it's harder to program. And so in this version of Dplyr, we have a new system called Tidyeval, which is basically a new framework for programming with Dplyr, or dealing with this type of problem in general. And so, you know, if you encounter this problem, you might say, well, I can't assign the bear variable name. Maybe I could try putting that inside a string. And that still doesn't work because it's looking for a column called group var. It's not looking inside that variable to find a G2. So to solve this problem, we have a new data structure called a quosure, which you can create with the quo function. So this basically kind of captures the expression. So this is what Dplyr is all about. It's about capturing what you want and evaluating it at a different time. So you know, when you do this in Dplyr, it's about capturing this expression and evaluating in a different context, in a context where you don't have to say which data frame every variable comes with. Or in the case of when you're talking to a database, the expression actually doesn't even get evaluated by R, it gets evaluated by the database much, much later on. So now we can use this quo function to kind of capture this variable. So we're saying we want to use this variable G1 later on. Now, unfortunately, that still doesn't work with group by. And what we need is some way to kind of unquote this variable. We just say, don't take this input literally, look inside this variable and see what it means. And so we now have this unquoting tool, bang, bang. And so what this tells Dplyr to do is don't look at group var literally, look at what's inside a group var and evaluate that. And so this gives us the ability to program with Dplyr. We can now create functions where you can write functions that work like Dplyr does. We can even take this further. You can not only do the grouping variables, but you can use this in every single function in Dplyr, whether it's summarize or mutate or mean or whatever. So this, I'm like 100% confident that the theory behind this is correct and robust and works like 100% of the time, not just 95% of the time. We are still working to like try and explain it in a way that you can understand. This is basically, it's sort of a similar level of complexity to learning how to write functions. So if my explanation right now just left you reeling and confused, do not blame yourself. That is my fault that I do not know a good way of explaining that yet, but we are working on that. You can always see kind of our latest efforts on the Dplyr website. There is an article about programming with Dplyr that explains the problem in much more depth, and we will keep rewriting that until we are confident that we've figured out a good way to explain what's going on here in a way that you can understand and then deploy in your own code. So that's all I had to talk about. Let's take a look at a few questions. Again, I'm just going to kind of skim through, and if anyone else from RStudio wants to like raise any questions to me, please do so. But I'll just take a quick look at these questions and see what might be of interest broadly. So one question is, what's the difference between this new system and the previous system, which used underscores after function names? It looked more like this. It used functions and it used formulas. And basically the problem with the old system is that there was no easy way to write code like this. You'd have to do something, and honestly, I think you have to write like interp, and then you have to do something like this, I think. And then you have to like say summary var equals. So basically the previous system of non-standard evaluation was extremely constrained, and it didn't actually help you solve the problems that you really needed to solve. So again, this new system, it's a little bit more complicated. It's going to take a little bit more work to understand what's going on. But I think that investing the time in that is really going to pay off, because it allows you to do more things in Dplyr, and we're going to be rolling out this system everywhere in the Tidyeverse. So hopefully in the next month or so, you'll be able to use the same system in TidyR. And by the end of the year, you'll be able to use the same system in ggplot2. So again, it's an investment. It's going to take a little bit of time to get your head around it. But once you do, you're going to be able to use it in many, many, many places. It's going to make programming with all of these kind of slightly magical functions designed for data analysis much, much easier. Yeah, so someone pointed out that quo and bang bang are kind of somewhat equivalent to bquote and eval. Yes, that is absolutely correct, although bquote only handles the expression, not the associated environment, which leads to subtle bugs. That again, sort of bquote kind of works like 95% of the time, which makes the 5% of the time it doesn't work really, really frustrating to debug. We've tried to move that pain kind of up front with Tidyeval. It's going to be a little bit more painful to learn it, but once you've learned it, there should be far fewer unpleasant surprises down the end. Bunch of questions about quo and in quo. Yes, so a lot of you spotted that I used quo in my example up here, but then I used in quo inside the function. The difference here is a little bit subtle, but quo basically always gives you its input back. So if I used quo inside this function, it's always going to put group var. But here I don't actually want group var. I want the value in the group var variable. I want to kind of go one level up to see what's inside that expression. And that's what in quo does rather than quo. So in quo captures exactly what's inside the parentheses. In quo, you use inside a function. It looks at that argument and see what expression was associated with that expression. A couple of people asked about whether CaseWin translates to SQL queries. That is a very good question that I will have to look at the source code to answer. It was definitely inspired by it. It looks like we do not currently have a translation for it, but CaseWin was inspired by the CaseWin function in SQL. So I'm just going to quickly file an issue so I don't forget to add a SQL translation for CaseWin. Add SQL translation for CaseWin. So we'll make sure that happens in the next version. So we had lots of questions about unquoting. Basically, there are, I kind of don't want to answer all of them here because they're fairly specific. But if you have any questions, do please read this programming article, which should hopefully answer your questions. If it does not, please let me know. You can shoot me an email or send an email to the manipulator programming list and we'll work. But basically, looking through the questions, if you did ask a question about this, the answer is yes, it is possible. It is similar to, it's kind of like macro variables in SAS, although those are just kind of work on the basis of text substitution. This is much more robust and works in a much wider range of situations.